Hello everyone. In this video, I am going to discussing about the how to derive a effective diameter of screw thread by 3-wire method. This method is most accurate method when compared to the 2-wire method for measurement of effective diameter of a screw thread. This method ensures a alignment of 3 wires which anvil faced parallel to the thread axis. Here 3 wires of known diameters are using, which having the diameter of the small d and placing one wire on the flank face of the screw thread. Another 2 are placing the opposite side. Then micrometer anvil is placed parallel to the thread axis. Let's see the geometry of the 3-wire method setup for a measurement of the effective diameter. Here capital M is the diameter over the wire which is measured by the micrometer, and capital E is the effective diameter. Let's see the maximized view of the any wire geometry. Here small d is the wire diameter and capital X is the thread angle and H is the depth of the thread, which is the distance between the crest to root, and P is the pitch of the thread, which is distance from one crest to another crest. So let us consider O is the center of the wire and draw a vertical line from the root F which passing through the center of the wire, and here d by 2 is the distance between the diameter over to the center of the wire. And next we have to draw a horizontal line at effective diameter of the thread. It intersects the vertical line at Q, and consider the H is the distance between the effective diameter and the center of the wire, and moreover here P by 2 is the distance between the crest and root. So now relation between the diameter over the wire, that is capital M, and effective diameter capital E is the E equal to M minus d by 2 minus d by 2 minus H minus H. Here d by 2 is the half of the wire diameter at top side as well as bottom side of the anvil setup. Moreover, here H is the distance between the effective diameter and center of the wire. One H for the top side, another H for the bottom side. So to get a E value, we have to determine the H value, that is the OQ, from the diagram. So for this, draw a line which perpendicular to the flank face and connect the center of the wire, that is the line OM. Similarly, draw a ON line which is perpendicular to the flank face and connect the center of the wire. Here we have to observe that when the triangle OMF is forming, which is a right angle triangle with an angle of the x by 2. So from the triangle OMF, sin x by 2 equal to the OM divided by OF. So then OF will become the OM into cosecant of x by 2. Then OF equal to, we know that we have to observe from the diagram, OM is nothing but radius of the wire, that is the d by 2 cosecant of x by 2. Then similarly here I have to observe the one more triangle. So one more right angle triangle is forming at the FST. So another right angle triangle is forming, that is the triangle FST. The angle is, which is the 90 minus x by 2. So here we have to observe one more triangle is forming, that is the triangle FS2 with an angle of the 90 minus x by 2. So from this triangle we have to write down the tan of 90 minus x by 2, which is equal to the TS divided by the Fs. So then TS will become the Fs into tan of 90 minus x by 2. From the diagram we have to observe that one, the TS is nothing but depth of the thread, that is the capital H. So H equal to tan of 90 minus x by 2 is nothing but cot x by 2. So one more thing in the diagram we have to observe that one, the Fs is nothing but P by 2. So then you have to observe, so then you have to insert the Fs value is the P by 2, then TS, that is the capital H, will become cot of x by 2 into P by 2. So now, so from the figure we have to observe that one, the QF is nothing but half of the depth of the thread, that is the QF is H by 2. Then QF equal to H by 2. H value we are determined from the triangle FST, that is the H equal to cot of x by 2 into P by 2. Then QF will become the half into cot of x by 2 into P by 2. Then QF value will become the P by 4 into the cot of x by 2. So then we have to determine the H value. H is nothing but OQ. So then OQ have to write down the OF minus QF. So OF we are determining from the triangle OMF, that value is the d by 2 into cosecant of x by 2. Similarly we are determining the QF value from the triangle FST, that is the P by 4 into cot of x by 2. Then H value will become the OF minus QF, that is the d by 2 into cosecant of x by 2 minus P by 4 into cot of x by 2. Then we know the effective diameter, that is the E equal to M minus D minus 2H. Then we have to insert the H value in the effective diameter equation. Then we will get the effective diameter, that is capital E equal to M minus D minus 2 into H value. H value previously we determined, that is the d by 2 into cosecant of x by 2 minus P by 4 into cot of x by 2. So then E value will become the M minus D minus of 2 into d by 2 cosecant of x by 2 minus P by 4 into cot of x by 2. Here 2 have to take the common, then the E equal to M minus D. So 2 will get cancelled, then D into cosecant of x by 2 minus of minus, it will become the plus P by 4 into 2, then the P by 2 cot of x by 2. Then you have to write down this one, E equal to M plus P by 2 into cot of x by 2 minus D, you have to take the common, then the 1 plus cosecant of x by 2. So we know the thread angle in the Whitworth type of the thread, that is the x value, that is 60 degrees in the case of the Whitworth thread. Then we have to insert the x equal to 60 in the effective diameter. Then we will get the E equal to D minus 0.6495 into the P. So here D is the major diameter. Similarly, in the case of the metric thread, we know the thread angle in the metric thread, that is the x equal to 55 degrees, and also having the one more relation, h equal to 0.64 p. Then we have to insert these two values, x value and h value. Then we will get the effective diameter E equal to d minus 0.64 into p. So we have to remember these two relation for the Whitworth thread as well as the metric thread. So this is the derivation for a find the effective diameter by the 3 wire method. So thank you.